Hi, welcome to Algebra 2. This is lesson 9.1 or 9.2, and we are working on two-way tables. So I am out today, so you guys are on your own, but you got this. So we can't do this as a class, but ideally we would see who can do an evil eyebrow and who can do a taco tongue. So evil eyebrow is when you can lift one eyebrow, taco tongue is when you can make your tongue like a taco. So we're going to pretend that this was the data. Five of us were no to evil taco, or no to evil eyebrow, but yes to taco tongue. Seven of us were no to evil eyebrow and no to taco tongue. So we're just filling in sort ofs. We're going to pretend that this was our data. If I add down each column, I had a total of 30 in the class. So just understand this. So 7 students could do evil eyebrow and taco tongue. So let's think of the probability of no evil eyebrow. So there was 12 people that had no evil eyebrow out of the 30. Sort of evil eyebrow, there was 10 evil eyebrow out of the 30. So what's the probability if someone was no evil eyebrow or sort of evil eyebrow? So no evil eyebrow, I'm going to look at these people, and sort of evil eyebrow, I'm going to look at these. So that gets me a total of 12 out of 30 plus 10 out of 30, which is what I got on the two right above this. So 22 out of 30. These events are called mutually exclusive. So this means they can't happen at the same time. So, for example, I can't do no evil eyebrow and sort of evil eyebrow at the same time. So mutually exclusive are two events that can't occur at the same time. So it cannot be a Tuesday and a Thursday at the same time. So once you have this, go to the next screen. So as we continue on, we're going to keep going back to that original data set that we had. So suppose you randomly choose someone from the class. The probability that someone is yes, taco tongue. There were 20 students that could do taco tongue out of the 30. Yes, evil eyebrow. So there's 8 out of the 30. Now let's think about the taco tongue, yes, taco tongue, or yes, evil eyebrow. There were students that could do both of them. So I'm going to think of it probability of taco tongue. Yes to taco tongue. Plus probability of yes, evil eyebrow. Minus the probability of both. So I'd have 20 over 30 plus 8 over 30 minus my 7 over 30. Just have 21 over 30. If we looked at our table above, I wish I could just easily flip up to it. it's this idea that if we did yes taco tongue and yes evil eyebrow, we're double counting this square, so we need to subtract it. So we wanted the 5 plus 8 plus 7 plus 1, but we needed to not make sure we didn't double count that, so we had to subtract it. Probably that we choose a random female in the class. Yes, evil eyebrow. Oh, choose a random student from the class. It'd be 20 out of 30. Yes, evil eyebrow given the person is yes taco tongue. So how many taco tongue people did I have? So on my chart now, yes taco tongue is, this is referring to the chart at the top. Yes taco tongue is of this whole group. So there was 20 of them. I want this 7. So out of the 20 taco tongues, only 7 could do eyebrow. The next part is yes evil eyebrow, given the person is no taco tongue. So this is based off the chart above, I just can't see it. So given that the person is evil, given the person is no taco tongue, so of all of these, I want the number that's yes to evil eyebrow. So there's 10 people with no taco tongue. Of those 10, 1 could do evil eyebrow. So what this is called, when you see the word given, this is called conditional probability. There's a condition in place first. So my condition here, so this person had to have taco tongue. So both of these had conditions. So based on our results in number 4, we see that a person is more likely. How does your ability to do taco tongue affect your ability to do evil eyebrow? If can do evil, or if can do taco tongue, more likely to be able to do evil eyebrow. Go ahead and flip to the back. So we kind of talked about some of these on the front page. Mutually exclusive means the events cannot occur together. An example is you cannot be a junior and a senior. An or problem is this idea that we can't have the overlap. So last class we learned just probability A and probability B. This works if they're mutually exclusive. No, I'm recording. It's all good. Guys, Miss Kula says hi. Remember, this is my idea of an overlap. So I can erase that, or I want to subtract that if I have an overlap. So if events are mutually exclusive, the probability of A and B is just 0. They can't happen at the same time. Conditional probability means so if you saw something like probability of A, we use this line given B. So this is saying probability given B. So I would think of this as number of events in B over number A and B. That's how I would think of that. So we're going to go ahead and do the check for understanding together. If a student was selected at random, what is probably that they are a senior who prefers math? So this is an and, this isn't an or. So this is probability of senior and math. So I have 250 students total. Senior and like math are 40. I'm going to do each problem in a different color so you guys can see. If a student who prefers math is rated children, what is probably they are a freshman? So this is a given. So it is given that they like math. So I'm only looking at my math students and I want to know if they're freshmen. So of all the math, so there is a total of 119 math. How many are freshmen? 20 are freshmen. If a freshman student is chosen at random, what is the probability that they like math? So this is switching that. This is the probability of math given freshman. So I'm selecting of the freshmen. There's 64 of them. How many like math? 20. Okay, last little section with this. I have the table again. Probability of freshmen and math. Oh. Thanks for being patient, you guys. I'm working around. Probably a freshman and math. So this is of all the students, 250 freshmen in math. I have 20 of them. Given that they are a junior or a senior, so of juniors and seniors, I have 65 plus 61 of them. How many of them like English? That chunk of them.